So good evening friends, I'm back with another video. From this video I'm going to start the main part, main content of the channel, that is discussing what I find interesting while I study. So right now I was studying geography and found a content pretty interesting. We experience it in daily life and we do not know what's the reason of it. So let's discuss it. The topic's name is inversion of temperature. You heard it right, inversion of temperature. So we have all studied in basic school geography that as we go to higher depths in troposphere, that is the first layer of atmosphere that is the closest to the surface of Earth. So as we go above, the temperature decreases. The rate of decrease of temperature is known as lapse rate. It is roughly around 6.5 degrees Celsius per kilometer of height. That means if we move 6.5 kilometers above, if we move 1 kilometer above the surface of the mean sea level, on an average, generally 6.5 degrees Celsius decrease in temperature occurs. So just a quick question. Let me know in the comments. What do you think? What will the temperature of tropopause? That is tropopause. That is the layer between the transition between troposphere and stratosphere. That is tropopause. So what do you think, tropopause has lower temperature at the equator or at the poles? Let me know in the comments. So let's get back to the topic, that is inversion of temperature. So as we know, as we discussed, there's a lapse rate of the Earth, but sometimes this lapse rate becomes negative. That is, as we go upward, temperature increases. So basically there are three types of lapse rate. First, the main type of lapse rate is three types of temperature inversion. The first type of temperature inversion is terrestrial temperature inversion. So what do you mean by that? We experience it in northern parts of India, in anywhere where there is condition of clear sky and there's cold night, and the conditions are pretty what to say, the wind is not moving, the conditions are, I would say, calm. So if you have a calm condition, there's the climate is very cold, the winter is very cold, and there is clear sky, we experience inversion of temperature. So what's the logic? Let's imagine this is the surface of Earth. So we all know surface of Earth acts as a black body. It receives the temperature, the heat from sun during the day, and we treat it as a black body. It releases all the heat to the atmosphere. It does not want to keep any heat to itself. So it keeps on radiating heat unless the heat reflects back. So if there's a cloud, the heat will reflect back. The greenhouse effects like carbon dioxide and methane pretty much do the same effect. But let's suppose there's no cloud. Cloud reflects a lot of heat actually. So if there's no cloud, there will be no reflection back. So what will happen in the cold winter? As we go deep into the night, the temperature of the surface decreases to very low level. This is because the rate of heat transfer, heat radiation by the Earth's surface is too high. So let's suppose this temperature, this surface of the Earth becomes very cold. So what happens due to conduction? The layer of air just above the surface in contact with the surface becomes extremely cold, and since the weather is very calm, there's no movement of air, this cold air becomes somewhat trapped, or this cold air mass is present all over the air, all over the area. It is cold air mass, and that's why this is called the temperature inversion. Lower temperature at the bottom and higher temperature at the top. The since air is a poor conductor of heat, the colder layer of air does not conduct heat from the upper warmer layer of the air of the atmosphere. So that's why this remains cold and this remains hot. So this is called temperature inversion. Temperature increases as we go above. So understood. This is observed in every night almost in northern plains. This also leads to foggy weather conditions because of the cold temperature. Clouds are formed at the lower near the surface only. This is called fog, and this is called temperature inversion. Now let's move to another type of inversion, that is advectional inversion. This let's imagine there's an island like Greenland. So Greenland has most of the time it has a layer of ice on its surface. So logically the surface becomes very cold and the air in contact becomes very cold. Now all around Greenland you have ocean, and we know in the night ocean is a bad conductor of heat, and something which is a bad conductor of heat is also a bad radiator of heat. That's why the air above the sea is warmer as compared to air above the land. The sea retains its heat during the night. So what happens? There's all and there's sea and there's air movement at the upper layer of the earth. This what happens in the lower surface at the lower surface there's cold air mass, and the upper layers warm air keeps on moving. So warm air, there's always a layer of warm air above and always a layer of cold air at the bottom. This is temperature inversion in Greenland and icy like conditions. This is called advectional inversion. The third type of inversion is valley inversion. I found it pretty interesting, so let's hear it. You must have gone to valleys like Kangra Valley, Nubra Valley, Shok Valley. These are in the northern plains of in the northern parts of Himalayas of India, in the Himalayas. So I would particularly discuss about V-shaped valleys over here, like something like this. There's this mountain, has a gorge, then again mountain and gorge. In between there's a space, this is called valley, a V-shaped valley. So what happens, since this is V-shaped, all through the day, the bottom part receives the least amount of sun rays because because of the shadows formed by the adjacent layers. If sun is this side, a shadow will be formed. If sunlight is coming from this side, a shadow will be formed at the bottom. It is only for a short duration of time that when the sun is at this point, that this part, that is the V part, the bottom part of the valley, will experience heat. So logically, this experiences a very less heat throughout the day, and this part, the middle part and the top part, receives a lot of heat in the day. Now, what happens when this experiences a lot of heat? It also releases a lot of heat during the night. There's a lot of space to release the heat, and the bottom part, whatever little heat it accumulates, it is not able to release it at as high rate as this part releases, the top part and the middle part. So what happens? Because of obvious reasons, that it is trapped over here by the two mountain layers, the two mountains. So at the bottom, this part becomes warm, this is cold. Now what happens? What happens that due to convection, what happens? The cold air moves down, then hot air moves up, and during the later part of the night, what happens? That in the middle and the top part of the mountain, there's warm air, and in the bottom part of the mountain, in the valley, the bottommost part of the valley, there's cold air. So what happens? What is this? This is called temperature inversion. It is colder at the bottom and warmer at the top. Now, what's the physical impact of it? The physical impact is you must have seen that in the valleys, there's no settlement at the bottom of the valley. There's most of the settlements are at the middle of the valley, not at the top, not at the bottom, in the middle. So what's the logic of it? The logic is because at the bottom, it becomes so cold that there's frost formation. At the top, there's release of so much heat that it leads to snow formation and frost formation. So neither this is habitable nor this part is habitable because you cannot grow crops. There's no cultivation of crops. There's no vegetation. So what part is left? Only the middle part. So at the middle part, this part and this part, there's a lot of settlement in the valley. Settlement will be found only in the middle part of the V-shaped valleys. That's mostly the case in 95% of the cases. So these are the main three types of temperature inversion which I studied and found them very interesting. Let me know if you found it interesting, and tell me in the comments the question which I asked. Just answer it in the comments, and I'll get back to you.